Tricky question than you might think. At a high level, you could say, in this game, in the game we're doing here, well, I want to grab my tokens, and I want to put them in the squares. Well, by the same argument, you could say, what you basically do is you mix hydrogen and oxygen, light it and fire it out of a tube. It's not rocket science. There's a few more details than that, it turns out. And it's actually very, very hard to get right. I'm going to give you an example of what's basically one of the great machines of technology, which is the humble ant. Ants are amazing. They are very dim. They don't have much in the way of brain power. And yet, without any kind of leadership, within a colony of ants, they build these incredibly intricate structures, have these sort of social groups. It's crazy amazing. But, has anyone heard of an ant mill? Okay, one. Okay, so ants find their way back to their colony via a pheromone trail. And occasionally, if an ant is really unlucky, part of that pheromone trail will dry up, and the pheromone trail will end up being in a loop. At which point, the entire colony will walk around this loop until they all die of exhaustion. The ant has had however many millions of years of evolution to get to where it is now, and it still does things like that. So there will be things which catch your robot out. So what we're going to do now is give you a handy technique for defining, making simpler the ways that your robot can move. A thing called a state machine, which I hope you'll all be using. Then I'm going to talk a bit about how things can fail and what to do about that. And then we're going to go to sort of open discussion about how you might compete in this game. But for the purpose of the state machine, just so I don't tell you all how to do it, I'm going to give you a game which we're not doing. A very simple fate game in an arena which looks like this. Your robots will start in the corners, and the goal is simply to pick up blocks in the middle and bring them back to your home zone. A very simple game. So how's this going to work? Well, the idea is, instead of just having a giant block of code which just kind of does everything, maybe dances, juggles, you break the way your robot works into states. And each state defines a very simple thing that it does in that state. So the very first state machine I'm going to say for this, once you build your robot to do this, it's going to do this. At the very start, it's going to go into a state called look for tokens, in which it turns around and waits until it sees a token. Now that on its own is going to be a pretty dull robot. It's going to start the match, find a token, go, yeah, that's a token. So it's something a little bit more complicated. Let's add a couple more states. So, you look for token, but suddenly you go, I've actually seen a token. So then, we change state. We go to a different state, which is the move to token state, in which your robot will drive forward, it's going to get that token. And once you realise you're actually really close, you're then going to go to another state, which is you grab the token. And then we can just kind of logically go on from here. Let's go down a bit more. What do we do once we grab the token? Well, we want to bring it back to our home, score points. So we're going to do the same sort of thing. We're going to look for home. Once we've seen it, we're going to move in that direction. And once we're close enough, we're going to drop the token. And the final piece of this puzzle, we then go back to the start and do it all over again. This is a very basic robot to do the game I described. And in an ideal world, that robot is going to do very, very well. But it turns out the real world doesn't quite work like that. See, in that diagram, we assume that everything that we try to do works. What actually happens is things will go wrong. Here's an example. So you've gone out, you've grabbed a token, and you go, okay, I need to go home now. Your robot begins to spin around, and look for home state, and go, okay, where is home? Unbeknownst to you, another enterprising team has had a robot come between you and your home, which is then broken down and caught fire. So you're pointed at your home, but you can't see your home over there, because there's a some smoke in the way and a dead robot. This is a way it can fail. So what are we going to do? We have to add extra states to deal with these kind of failures. So in this case, the simplest thing I think is going to be this. If we look at home and we get past 12 seconds and we go, okay, we can't see home now. Something is wrong. We'll go to another state. What we're going to do is move kind of randomly, just kind of in any direction, and hope that we can then see home. 5 seconds after we move randomly, we go back to look for the home state. That's a really simple change to your state machine. But it means that you no longer have to worry anywhere near as much about the situation where suddenly you can't see where your home is. Here's another example. You've gone to grab your block, you've charged at it, you're putting the fear of God into it, and along comes a team with a very fast robot who snatch it up as you're lowering your grabber, and your grabber then just closes on thin air, lifts, and you go, huh, I haven't got a token. Guess I've got to grab it again. This is not unusual to have go up to a token, have it disappear, and then have a robot just sit there for an entire game going. So we'll deal with that as well. Now that's actually a really easy one to deal with. We can't grab a token, we fail to grab a token, we'll just go straight back to the look at token state. We'll say where we are, spin around and find another one. Go and get that. That one is a really easy change. Again, another situation which won't leave you forlornly sitting in the middle of the arena. All right, here's a slightly more complicated one. You've gone to move to your home. You've gone to move to home state. But another very careless robot, built by a team who decided that bump sensors, you don't really need those. They've now careered into you and knocked you massively off course. You then aimed at a completely different section of wall, and then you ran into the wall and you repeatedly go into the wall thinking, clear not to have got home yet. Once again, easy fix. If we can't get home, we'll just go back to the look home state, spin around. And here's just a slightly more complicated one. This is maybe not the best way to do it. This is just to get you thinking about the ways which you might take your state machine and modify it to add behaviors to get around things which can stop your robot. The problem is, here, you can't drop your token. Your token is jammed in your grabber, somehow, and you're unable to get rid of it. It's like you've got, it's sticky or something. Here's a possible suggestion. If we can't drop the token, we're going to drive forwards at full speed, and then we'll drive backwards at full speed in the hope that it's dislodged. It's only an extra couple of states. This one's a bit more. This one's a bit less obvious, right? This is something you might think, okay, that's not the first thing I'd think of. But all these little things add up. You just add, instead of just having this one giant program, you can split your program up into states. Each state is really very simple. And you say, when this happens, we'll just go to the next state. It's a way of dividing your code and having your robot work in a sensible way without crazy spaghetti everywhere. Not literal spaghetti, spaghetti code. So, how does this all come together? Well, one thing to bear in mind is that your robots are disobedient. And what I mean by that is, they won't do what you think you've told them to do. See, there's a thing called manufacturing tolerances, which turns out to be a bit of a problem. In fact, there's any number of reasons why things might work slightly differently. So, you have your robot, you've got a wheel on either side, and you say, okay, I need to go in a straight line. I'm going to set this motor going at this speed, and this motor going at this speed. It is almost guaranteed you're going to drift off to one side. Almost guaranteed. If you think you're going to go some set distance, you're never going to go that set distance. If you think you're going to turn some set angle, you're never going to turn that set angle. In fact, there's a whole section of engineering, it's called control. Basically, you can't just dead reckon on how things are going to work. You've got to stop, you've got to have your robot stop and realise, okay, where am I now, and adjust for these little errors. Which also leads me on to my next point, which is test without human intervention. Now, I've mentored quite a few teams, particularly at Tech Days, and there's one thing I see repeatedly, which is teams thinking, okay, I've got this robot, it needs to go in a straight line. And they'll go to one end of the corridor, they'll put down their robot, and they'll set it to go, and it will go, and it will drift, and it will drift, and they'll pick it up and turn it, and it will kind of go and kind of drift and drift, and they'll pick it up and turn it again. And it describes this sort of bouncing arc. And it'll get to the end of the corridor, and they'll go, oh, that's great, our robot drives in a straight line. And then act kind of surprised when they put it in an arena where you'll get disqualified very, very quickly if you try and fiddle with it and go, oh, that's strange. Appears to have gone into the wall. Test in the situation that it's going to be in. So if you can, build yourself a very simple arena out of upturned tables or whatever. If you can test these things in situ, it will be so much easier. Brings me on to the last bit of this, which is decisions. Now, in the state machine I gave earlier, things were very simple. You go for the first token you see. In practice, you can get lots of information and then make smart decisions about what you're going to do. This is where I'm going to open things up. So now we're going to talk in context of this year's game. So your robot started off in this year's game. You grabbed yourself a token, and you now need to go and put it in a square. The question is this: which square do you choose? You can choose the one closest to you, or you go for the one furthest away, or you go for the one in the middle. Which one might you choose? Any ideas? Up the back? Sorry? All of them have blends. Okay, so yeah, that's one thing you might be able to do. You have a look and then realise, okay, so I could go for this zone here, but somebody's already captured that. Like, if I put a token here, I'm just wasting points. So you can make a decision based on what other robots have done and what brings you the most benefit. Any other ideas?
Well, as closest to you, you'd have to move as far as you get to it.
Yeah, very, very sensible. Gives you the most points for the least amount of time in the game. Because time's a really limited resource when you've only got 3 minutes. Any other thoughts?
If you put it on the middle one, it's probably harder for the other ones to get to.
Yeah, it's a great thought. So the middle one is going to be the furthest from, on average, from every other team. If you go straight from the middle, you can dump it there. You might have more of a chance of not having another robot come and take it. Okay, so kind of good ideas here. So you've taken this square now. Square is yours. You've, I don't know, maybe put it on the plinth if you're pretty good. What do you do now? You could go straight back home, pick up another token, rinse and repeat. Or you could start getting aggressive. Now, other robots may have come and taken squares of their own. We can't have that. We can't have other robots taking our points. So what we can do is we can get cruel. We're going to go and steal other robots' tokens out of their squares, put them back somewhere where they're not needed, deprive other teams of their points. On the other hand, if we do that, there's a sort of opportunity cost. That's more time we've spent going and getting theirs while they're doing something else. It's now further for us to go back home. What kind of things might we do here? What are our options?
Can we do something on the way back that you were going anyway that might attract somebody else?
Yeah, so you could look at it from a kind of opportunistic point of view. I want to go back home and collect another token, but if there's something I can do on the way to irritate another team, brilliant, I'll do that. Any other thoughts about things you might be trying to do? Anyone?
You could keep track of the number of areas you think you've got, and once you've got a target number, you can then go and break other people's.
Yeah, brilliant. So you can kind of keep track internally instead of just blindly going, okay, now I'm going to pick this thing up, put it down, pick one up, pick it down. You realise, okay, I've already put down this number. I think I've got this many squares, and then you can make a decision about how you think. You can make a sort of big picture decision. You can get a sort of picture of how everything in the arena is out, how many squares you've got, and go, okay, I've got enough squares now. Now I'm going to go on the offensive. So it's often a really good idea to kind of keep track of what's going on. Anyone else got thoughts?
If you think you're keeping track of it, you need to check every now and then.
Yeah, very good point.
it's still all you think it is.
Yes, things will change. Boxes will be pushed. Insert kind of arrow morning type speech here. Things will be broken. You've got to keep an eye on what the situation is, because it will change very quickly. You can think you've got all the squares. Turns out some cruel robot has come in with a net and swept up all your tokens and is now making them into some topiary statue. So you've got to keep an eye. Any thoughts from anyone else? Ah, the old switcheroo. Yeah, just like Indiana Jones with it on. Yes, hopefully without the giant rolling ball of doom. Yeah, you can come and take somebody else's square. So deliberately go, okay, I'm going to now take away yours and put mine down. So you're not just taking squares, you're taking squares at the same time to deprive other teams of the square. Any other thoughts?
Kidnap other people's tokens?
Kidnap their tokens and hold them hostage. I think we might be getting a bit excessive there. I think that would be poor sportsmanship. Okay, cool. Final thing to keep in mind, ultimately, scoring points in the game is great. But what matters isn't really the game. It's where you come relative to your opposition. It's the lead points. This is the thing about the opportunity. It doesn't matter if you only get 2 points in your game. It doesn't matter if you only get 1 point in your game. As long as you have made sure that nobody else has more than you do. If you can beat other people in the most non-contact violent way into submission and claim the arena as your own, it doesn't matter how badly you've done, or how badly in game points terms you've done. What you need to do is beat your opponent. This is ultimately a competition. So the basic points of the tactics are, use state machines, think about your decisions, think particularly about the ways that things can fail, and make sure you keep in mind the big picture and how you're going to win the competition, not just the game points. Any questions? Yeah? Blind. It's the projector light, I can't see.
I was wondering about what is the highest scoring position? So, what is the best way to arrange your 6 cubes? So you score the highest points.
That's an excellent question. I suspect there are bonus points for getting cubes in lines in some direction. So I suspect the best configuration is to probably get 2 columns or 2 rows and put your tokens on the split. But I don't actually know. We haven't done the maths on the scoring system. If anyone would like to figure it out and post on the forums, that would be awesome.
It's a supplementary question to Carl's. What we were trying to work out at lunchtime was whether each square only counts once. So if you've got 2 parallel rows, does that mean that you get some of the squares are counting both cross and down? And that was the bit we didn't know yet because we haven't seen the rows.
Ooh.
Oh, I see what you mean.
Each square only counts once.
Yeah. Anyone else? Okay, great. Thank you very much.